In this video, we'll see how to use the slope formula, and the focus will be on negative slope this time. Negative slope means that the line will be inclined downward towards the right hand side. So down to the right is negative slope. When we draw a line, we always look at the right side of it, and a negative tilt is downward direction toward the right. Slope is the representation of lowercase m. Another way of saying difference of the y-coordinates is delta y. Delta stands for difference. So difference of the y-coordinates, difference of the x-coordinates. That is y difference over x difference, or ratio of vertical count over horizontal count, which in the formula is subtracting the y-coordinates on the numerator and then subtracting the x-coordinates of the denominator. So vertically, y-coordinates we subtract, horizontally x-coordinates we subtract. To see the negative slope, we plot the points -6, 0, 0, -3, 2, -4, and 6, -6. Plotting the points is resulting to a downward direction, or steepness leaning down to the right, which is the sign of the slope. The ratio between the points is vertical to horizontal, so between any two points the ratio has to be the same. So when we identify first those ratio rectangles, they may seem different size, but then after we simplify, they all should be the same. So let's start with the biggest one. The biggest one, I have 3 by 1, 2, 3, 4, 5, 6. So I have negative steepness for the slope, and then the ratio of 3 by 6. So -3 by 6. Then this one is 1 by 2, which is the smallest one. This one is 2 by 4. So if I have 3 by 6 and -1 by 2 and -2 by 4, they seem to be different, but after we simplify, they all are the same. So -1/2 is the simplest of all of them, and that's the shortest distance between. If I divide 3 and 6 by 2, I have -1 by 3, I'm sorry. I have -1 by 2, and if I divide 2 and 4 by 2, I have -1 by 2. So the slope is -1 by 2 all the way throughout. So if I start with my top point and I go 1 by 2, 1 by 2, I can fill in those distances, showing that it works all the way throughout the line. I can even extend on the outside that the line has the same rate of change. For every 1 square down, I'm going 2 across. For every 1 vertical, there is 2 horizontal, and that works all the way throughout the line. That is reading the slope from the graph. To use the slope formula, you need 2 points. Which 2 points? Any 2 that are given in the chart. So let's say I'm using the first point, -6, 0, and last one, 6, -6. On the numerator, I am subtracting the y-coordinates, so 0, subtract -6. On the denominator, we need to subtract in the same order, -6, and then subtract the 6, the x-coordinates. So y-coordinates subtracted on the numerator, x-coordinates subtracted on the denominator. 0 minus -6 will be +6. -6 combined with -6, or -6 minus 6, will be -12, and the numbers keep the sign. When we simplify, positive divided by negative is negative, and dividing by 6 to simplify, we have 1 over 2. So this slope is the same as visually on the graph. Let's pick another combination. So let's say I pick point 0, -3 and 2, -4. So I pick any 2 points, because in order to find the slope, you can pick any 2 points in the given chart or on the given line. Numerator, subtracting the x-coordinates, -3, and then we subtract -4. In the same order, subtract the x-coordinates, but on the denominator 0 and subtract 2. -3 minus -4, that would be -3 plus 4, which is 1. 0 minus 2 is -2. When we simplify, positive divided by negative is negative, so it's negative direction of the line of the steepness 1/2, vertical over horizontal. Negative direction 1/2. If the problem says find the slope between the 2 points and the numbers are small, one option is to plot on the coordinate plane. So draw a little coordinate plane, plot the points, and count the ratio of vertical to horizontal distance. So first we're going to start with graph. That means -4, 3 plot point, and 2, 1 plot points. This is helping with visualizing the sign of the slope. So negative slope, which is represented by the direction of the line down to the right. So the slope has to be negative. Negative what? What is the steepness? So then we start looking at the ratio rectangle between point to point, and that will be vertical over horizontal, or rise over run. So vertically we have 2, horizontally we have 1, 2, 3, 4, 5, 6. That will simplify to negative, and if you divide by 2, we have 1/3. Let's check if that works throughout the line. So from point to point, down 1, 1, 2, 3 across, you're on the line. Down 1, 1, 2, 3 across, you're on the line. Down 1, 1, 2, 3 across, you're on the line. And you can extend it either way to see that that same rate of change is working throughout the line. For every square down, there are 3 across. 1/3 vertical over horizontal, negative direction. To calculate the slope using the slope formula, you need 2 points. So those are the 2 points given in the problem. I like to write them in the vertical chart because when you subtract the coordinates, it's simpler to identify them. So 3 minus 1, the y coordinate subtracted on the numerator, y2 minus y1, so second point and first point. And then in the same order, -4 and 2. 3 minus 1 would be 2. 4 minus 2, -4 minus 2 would be -6. Then we simplify. Positive divided by negative is negative, and 2 and 6 can be divided by 2. So that results to the same slope, -1/3, which we had from graph. When the numbers are bigger, so to find the slope from 2 points and you have bigger numbers, the graphing is not efficient, but slope formula is what we would use. So when it comes to big numbers, graphing is not the best way to find the slope. However, what helps is the sketch. The sketch will help identify the direction of the line, which helps with the sign of the slope and then estimating the numbers. So the sketch is not a must, but it's helpful. So I'll go again by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, -10, 20, 30, 40, 50, and then there is no negative y, but I'll still put a few dashes there just for the sketch purposes. So 2398, that means I'm going for x23, 1, 2, that's 10, 20, and then stay a little bit past 20, and then I go 98, so almost to 100. 1, 2, or 10, 20, 30, 40, 50, 60, 70, 80, 98. So about right here. Then 67, 32. 10, 20, 30, 40, 50, 67, about 70 or close to 70, and up past 30. 1, 10, 20, 32. Maybe like right here. The sketch is not giving you the exact count because it's not very accurate, but it's giving you the orientation of the line, so you can have an expectation in mind when you actually use the slope formula. So if you're getting a negative slope, that's good, and if you're getting a positive, then you can start checking for the mistakes that you made. In the chart, I like to use a vertical lineup in order to identify my x and y coordinates. So first point, ordered pair, was 2398. Second is 6732. On the numerator, we subtract the y coordinates, so that would be 98 minus 32. On the denominator, we subtract the x coordinates, 23 minus 67, 98 minus 32. (23 minus 67). And in this situation, we can simplify. So 66 over 44, we have negative because positive divided by negative is negative. First, we can divide by 11. That would be 6 over 4. And then we can divide by 2. That would be negative 3 over 2. A good way to check if we simplified correctly or if we subtract correctly is definitely using calculator, but at the same time here the fraction is easy to see what it would be, but in a more difficult situation you can divide numerator by denominator to see if you have the same equivalent decimal as your simplified fraction. So let's say when I divided 66 over 44, I have 1.5, which is a unit rate, so that is the same as 3 divided by 2, which is 1.5, which is the same unit rate. So it's a good way to self-check if the simplification of the fraction was done correctly. Negative, and our sketch was negative as well. To find the slope from graph, what we have to do, if the points are not identified, we have to identify them and then plug them in the slope formula to see if the same ratio is what is on the graph and through the formula. So by looking at my line, I see the negative inclination because the right side of the line is pointing down to the right, so that is a negative slope. Then I need to identify a few points, so that one is easy to read. Carefully look at the scale to make sure that that point is read correctly, so that is 0.3. Then you have to look for other points that you can read. So by looking at the line, look for the intersection of the grid lines to see what point can be read to the precision of whole ordered pairs. So we have 4, 2. So negative 4, 4, 0, 3, and 4, 2. From here you can read the ratio and you can use any 2 points to confirm that ratio. So let's say if I was to read it off the graph, I would say this is negative 1/4. Let's see if that works. So pick any 2 points from the chart. So let's say the first two, 0, 3 and negative 4, 4. Then subtract the y coordinates on the numerator. That would be 3 minus 4. Subtract the x coordinates on the denominator. That would be 0. Subtract negative 4, so minus minus 4. 3 minus 4 would be negative 1. And then 0 minus minus 4 is like 0 plus 4, so that would be positive 4. And simplifying, negative divided by positive is negative, which is the direction of the line with the steepness of 1/4. So that is matching with what I have on the graph. Careful when you look at the scales. So when you start reading the points, analyze carefully the scales, because when you count, the slope is not the same as the value of the vertical distance by looking at the scale numbers. So I have the y-axis going by hundreds and the x-axis by tens. So careful when you identify the points. Reading the slope of the graph, if the scales are not the same, will affect the result of the slope. Let's see what that means. So let's say I can read this point clearly, this one, and this one. The other ones are not going through exact intersection. So I'm going to use point 0,700 and then 5,500. And then the other point that I have is 100 to y value 300. So what I can see from this chart is that I have a negative orientation of the slope. So the steepness is downward to the right, which is negative. And then I'm going to use two numbers or two ordered pairs to find the exact slope. So let's say, use the first two numbers. 0,700 and 5,500. On the numerator, subtracting the y coordinates is 700 minus 500. On the denominator, in the same order, subtract the x coordinates, 0 minus 50. And then we have 700 minus 500 would be 200 divided by negative 50. Positive divided by negative is negative, which is my direction of the line. And then I can divide by 10 to simplify the fraction. That'll be 20 over 5, which can be simplified a little bit further by dividing by 5. And that would be negative 4 over 1. So this is when I was saying how the different scales affect your steepness by counting. So this is negative direction. The only thing that we can see here clearly is negative. But 4 over 1 is not visible in this particular situation because the scale on the y-axis was going by 100 and the scale on the x-axis were going by 10. So that stretched the steepness to a different number count. So careful when you use the scales. And this is when the slope formula comes in place and not the counting on the units on the coordinate plane.